Okay, now we have established that a s orbital can hold a maximum of 2 electrons. A p orbital can hold a maximum of 6 electrons. A d orbital, I'm just summarizing what was in the earlier sequence, so it seems to go along well. A d orbital seems to have a maximum of 10 electrons, and a f orbital can hold a maximum of 14 electrons. Okay, now this is kind of where we stopped in the previous sequence. Now before we get further, I want to caution you, because at least you are in the online class, so you always have access to materials when you take your test, quizzes, or homeworks. But people in a lecture based may not have that option, because we won't provide some of that actually on a test. Okay, so since I'm doing it, I want you to understand it. So even if you're going to use your material, it seems quite easy for you, then have to memorize it even with your notes in hand, and that's always a tough thing to do. Okay, so I'm going to take you to my PowerPoint that's are also on the Moodle shell for week 1. Is this okay? I am going to take you here. Okay, this is something I have created. I'm going to load everything on the screen. Okay, all right. So there's multiple ways people have approached how to understand this orbital arrangement, which eventually will lead you to understand electron configuration. Okay, so this is my take on it. I will also show you how universally it's done across classrooms and explain why that also leads to some confusion, why you may also find my method confusion, but I'm going to explain everything and you pick and choose which one works the best for you. Okay, as you do your quizzes, homeworks, or tests, whatever, you pick what works best for you, because there's always a comfort zone that we always lean back to. All right, so every element is arranged in rows and column fashion, as you see. Here we're just simply going to focus from a row perspective, because it is super easy. Okay, the first elements obviously are in first row, the second set of elements are in second row, the third set of elements are in third row, the fourth set are obviously in fourth row, etc., etc. Okay, so because it's in the first row, it gets number 1, and elements in the first row get a s orbital notation. Now as you go to the second row of elements, starting from lithium, beryllium, boron, carbon, nitrogen, you see that arrow goes from beryllium straight to boron, not anywhere else in the periodic table, because that's the sequence, because your atomic number is 3, 4, and then 5, not anything else. So that seems to make sense. So they're in the second row, they get 2, and they, remember I said there's 2 elements in the periodic table that have only a orbital. The rest of the elements in the periodic table have orbitals. Okay, now let's stop here and look at what we have talked so far. Okay, so say you're looking at boron, which is B, number 5, atomic number 5. Okay, to get to boron, you've got to go through 2 levels before you can get to boron. Okay, now here's what students misunderstand. Now when I said in my welcome video, when I do the video that incorporates student problems, it's much more easier than just, it's much more valuable than just making a video that is generic about any chemistry topic. Okay, so what I'm saying here is, to get to boron, okay, you've got to go through the first level elements. Okay, so you've got 1s. Now what students do is they write 1s 1s. Okay, irrespective of which method they have learned and from which instructor, they write 1s 1s. No, you can't repeat the orbital twice, and a number and orbital shell can only appear once in the entire notation. Okay, you cannot have 1s 1s. 1s can only appear once. So is anything else that you write can only appear once. Okay, so 1s is the first row for 1, and it only has a s orbital. Okay, and then we want to get to boron. That's our final destination. Okay, we're done with the first row, 1s once. Before boron, there are two more elements in the second row, and the first two elements on the second row get 2, which is common throughout the row, but then the first two elements are in the S category. Okay, even if you look at your actual periodic table, which will, when we come back to explain and do this as an exercise, I'll show you, okay, those two elements are in the S bracket, so that's 2S. And now you've got your boron, which is part of the 2p category because it's in the second row, but it's part of the p group, so it's 2p. Okay, so you don't say 1s, 1s, 2s, 2s, 2p. You say 1s, 2s, 2p. So now we got 3 orbitals. 1s is 1, 2s is 1, 2p is 1. Okay, 3 orbitals. Okay, like I said, there's 2 elements in the periodic table that only have an orbital around a nucleus. All other elements have more than 1 orbital around the nucleus. So boron would have 1s, 2s, and 2p. Okay, we will learn further down the road that 2p has 3 subdivisions, but let's not focus on that right now. Okay, let's say we're trying to get to magnesium, which is in the third row, Mg, atomic number 12. Okay, we got to get through 2 rows first before we can even look at the third row. So as I said, you cannot repeat orbitals just because they appear, there's that many elements, you cannot have that many repetitions of the orbitals. So you get through row 1, so only 1s. You get through row 2, you write 2s once, 2p once, okay, because that's the sequence you got to follow. Okay, 2p and then comes 3s. You see the arrow doesn't go from 2p to 3p, it only goes from 2p logically to a 3s, and you stop there because we've got our destination, magnesium. You don't want to go past your destination, you want to stop there. Let's say we're trying to focus phosphorus, which is also in the third row, but there is a 3s ahead of the 3p. So if you were to think of our orbitals around the nucleus, it would have to be 1s, 2s, 2p, 3s, and then 3p. You don't need to say 3p, 3p, 3p until you get to phosphorus, just once. Okay, now this is my method that I have. Say if there's 100 students in my class, 70 like this. Okay, and I'm going to teach you the remaining 2. One of them requires pure memorization. If you're really good at memorization, then you can go with the third method. The second method, obviously you're in front of your computer, whatever you do, so for you it really is not such a big deal, but for people that are learning, or if you're really interested in learning, then any of the 3 methods would work. Okay, so I'm going to go back now to my tablet version and then show you how to use this in terms of the shell, and then we'll come back and learn the other 2 methods, and you decide what works best for you. Okay.